Hey guys, today we're going to talk about special right triangles. Okay, if you remember last time, there was kind of a embarrassing moment that I had when, I just didn't even realize that I was working with a special right triangle when I was using the distance formula. So we're going to go back to the same problem. Yes, the same problem again. I know. And we're going to take a look at where I messed up, why I messed up, and we're going to tie it all in to special right triangles. Let's go. Okay, wait. Before we talk about the embarrassing moment, again, and you'll have to see the last video to see the embarrassing moment, happened towards the end, but yeah, anyway. Before we go over that embarrassing moment, I realized I need to go over special right triangles. So I had another embarrassing moment. But anyway, just have fun laughing. I can hear you through the camera, but that's okay. That's all right. Okay. Special right triangles. You might ask, why do we even need to know about special right triangles? And I remember when I was teaching, I used to hear that all the time. Why? We got the Pythagorean theorem. Why do we need to know about the special right triangles? Well, because sometimes it's easier to just know the length of a triangle when you're just given the values, the distance, the sides. Instead of calculating, using the distance formula, when there are patterns, you can just, it can just pop in your head. So let's take a look at some of those patterns, okay? Now, when it comes to special right triangles, we have two types, and these are the only types that you'll have to memorize, okay? But it's easy. You'll kind of see the pattern here as we go along, okay? So for 30, 60, 90 right triangles, that means that you have a 30 degree, 60 degree, 90 degree, of course, right triangle in your triangle here. And notice that all the angles in a triangle add up to what? 180. Okay, very good. So the sides of a right triangle that has a 30 degree, 60 degree, and 90 degree angles have a special relationship. And that special relationship is 1, 2, square root of 3. If you can remember to do that, you're on your way. And what that means is the sides of these opposite of these angles here have that relationship. So if the side of this 30 degree angle, for instance, was a unit of 1, okay, then that means that we can assume that the length of the side opposite of the 90 degree angle is what? It's 2. And then the only thing left is the side opposite of the 60 degree angle, which is the square root of 3. So that's what that means. So for all your angles, okay, in your special right triangle, these ratios right here represent the sides opposite of each of these angles here, okay? So we're going to do the same thing for a 45, 45, 90 as well, okay? So that means that we have a right triangle that has 45 degrees, 45 degrees, and then 90 degrees. So it has two 45 degree angles and a 90 degree angle, and that adds up to what? 180. Very good. Okay, so now the special relationship that they have, or their sides that are opposite of these angles have, is this. 1, 1, square root of 2. If you can remember that, you're done. Okay, so what that means is the side opposite of one of the 45-degree angles is 1 unit. The side opposite of the other 45-degree angle is 1 unit. And the only thing left is the side opposite of your 90-degree angle, which is the square root of 2. Okay? And these are your base simplified ratio relationships or proportions among these sides here. Okay? So you have two types of special right triangles. Okay? The first one is the 30, 60, 90. You'll hear that a lot. And then the second is the 45, 45, 90. And that's the other one you'll hear a lot. Okay? So now, let's work some problems to make this make some sense.